This is the Unit 4 Algebraic Geometry Practice Test Answer Key video. Looking at number 1. Draw and label the diameter, radius, and circumference of the circle below. So, the circle along the outside is a circumference. Okay. The diameter goes all the way through the circle through the midpoint. The radius goes from the midpoint out to any section or any place on the outside of the circle. So we have the diameter going all the way across, the radius going halfway, the circumference around the outside. Questions about number 1? Okay, going up to number 2. Fill in the blank. To find pi, mathematicians divide the blank by the diameter of the circle. Pi is the relationship between the circumference and the diameter. So, the correct answer for number 2, we relate the circumference and the diameter of the circle to find pi. Questions about number 2? It's in our notes. Number 3. Jimmy Bob needs to find the amount of fencing to go around his circular pool. Which expression or expressions can he use? So if we're looking for the amount of fencing that goes around the outside of the circular pool, we're looking for the circumference. There are 2 formulas for circumference. Circumference is either equal to 2 times pi times our radius, or pi times our diameter. On your test, make sure that you include both. Yes? That's area. Okay. Remember, with the circumference, we do not square the radius. Yes, ma'am?
What if we only do one of them? Does that happen?
If you did one of them, you get half credit.
Wait,
Yes.
if I put pi times r,
With the exponent of 2,
yeah, is that right?
that would be the area, not the circumference. So that would not be correct. Okay? Alright, any other questions about number 3? Alright, number 4. Jimmy Bob's pool has a diameter of 15 feet. What is the smallest area his pool cover can be? So here I need the area of a circle, which is pi times my radius squared, which would be great, except that the problem gave us a diameter and not the radius. We know that the diameter is equal to 2 times our radius. If I divide, I'm going to need to divide both sides by 2 to find the radius. 15 equals 2r. 2r, divide by both sides by 2. 15 divided by 2 is 7.5. 7.5 feet equals my radius. So, then I can use this information to solve for my area. Pi we use as approximation as 3.14 times my radius of 7.5, and we square it. 3.14 times 7.5 squared is 176.625. We are going to round to 2 decimal places, which gives us 176.63 feet squared. This is the final answer that I need. Yes?
What if we don't round to 3?
If you don't round to 2 decimal places?
Is that okay?
Yeah, that's fine.
Okay, and to find the area, no, radius,
Mm-hmm.
all I did was 15 divided by 2.
That's fine.
Okay.
If you didn't show me this part, but you just took 15 divided by 2, that's fine.
That's all I did.
Yeah, that's fine.
Okay.
Yes. Yes. All right, moving right along. Looking at numbers 5, 6, and 7. 5, 6, and 7 are all related. It says use a diagram to name a set of complementary angles. Complementary angles measure how many degrees? 90. So, because we have a right angle symbol here, that tells us that angle 10 and angle 11 are complementary, or angle 12 and angle 13. Okay, so angle 12 and angle 13, or angle 10 and angle 11. Because we do not have any right angle symbols anywhere else, we cannot confirm that those would be exactly 90 degrees. Yes?
For why can't, since the right angle box is at the 9, why can't 9 and 10 be 1?
9 and 10?
Yeah.
Because 9 and 10 combined have a sum of more than 90 degrees. The sum of those two angles, so the two angles put together have to equal 90. So, angle 10 and angle 11, put those together and we get 90 degrees. If angle 9 is 90 degrees all by itself, then it can't pair with anything to be complementary. It's going to be too big. Yes?
Oh, no. The little, like, triangle thing, is that an A or is it like a... No, like what you want.
Okay, let me rewrite this because it's kind of sloppy. Angle 10 and angle 11, or angle 12 and angle 13.
So, do you need to put little angles down?
I recommend that you do. If you don't, I'm not going to take off for it this time. Okay. You do have to give me a correct pairing. You do not have to give me both. Okay? Let me think about it. Alright, any other questions about number 5? Alright, looking at number 6. Using the diagram, choose a set of supplementary angles. For this, I'm going to just say see diagram. Because supplementary angles, we have many. Angle 1 and angle 2 are supplementary. Angle 1 and angle 5 are supplementary. Angle 2 and angle 6 are supplementary. Angle 5 and angle 6 are supplementary. Okay? You could also say angle 3 and angle 7. Angle 4 and angle 8, angle 3 and angle 4, angle 8 and angle 7. We also have, so what we're saying is that those are all sets of supplementary angles.
Do you need to do that on the test?
No, you just need to give me one of those sets. But there are 1, 2, 3, 4... There are a minimum of 8 sets of supplementary angles. Instead of writing them all out, choose any set that's next to each other that forms a straight line. Yes?
Will 9, 10, 11 be 1?
9, 10, and 11 could work too as well, yes. So could 11, 14, 13, and 9, 10, 9, and 12, and 12, 13, 14. There's lots. That's why we aren't doing them all. Okay? Alrighty. Number 7. If the measure of angle 4 is 52 degrees, what is the measure of angle 7? So, we have angle 4 and angle 7. What is the relationship of angle 4 to angle 7?
They're vertical.
Okay, they're vertical angles. So, I'm going to put as my answer 52 degrees because they are vertical angles. Because angle 4 is across from angle 7, that means that they're vertical angles. Vertical angles are congruent, which means that they have the same angle measure.
Oh, so on the test you need to like solve it?
No, you just need to recognize that they're vertical angles so the angle measure is the same. Okay?
Oh, okay.
Yes. Yes. Okay. Number 8. Use the picture below to find the missing angle measures. It says that the thin line, so this angle here, the big one, is 112 degrees. So we need to find the measure of the dotted angle and the measure of the thick angle. Alright, I'm going to find the dotted first. Okay, and the dotted is represented by the variable x. So we know that from here to here is 112 degrees. We also know that part of that is 90 degrees.
Well,
Yes, ma'am.
guess what tile is inside now?
All right, I'll send her. Thank you.
Thank you.
Okay. That tells us that 112 degrees minus 90 degrees will equal x. The thin line goes from here and includes the right angle that's formed.
I don't understand where you got 9.
Hold on. So, the dotted angle, x, is 22 degrees. Okay. We know that the 90 degrees came from the right angle, which that box right there tells us that that is a right angle, and right angles measure 90 degrees. Hold on. So, because we knew that this whole angle here was 112, we knew that this part was 90. So, 90 plus the 22 from the dotted angle equals 112.
Wait, I thought we were trying to solve for the thick.
We were doing the dotted line first. Now we're going to solve for the thick line. Yes.
Since that right angle box is in 112, why does it go for the dotted line?
Because the 112 includes both adjacent angles.
Oh, because the dotted line is in the thin line?
Right. The dotted line is inside the thin line angle.
Okay, so I'm going to like, all you really have to do is what I did was 112 minus 190. No, what's 180? 180.
You did 180 minus 112? Okay, so that's how we would find the thick line.
So I thought that's the only line to solve, right?
So I didn't find the missing angle measures. So we needed to find both. Okay. So now I can solve for the thick line. Okay, we're going to call that variable y. There are two different ways that we can do this. Option 1, we know that this side also has to be 90 degrees. So we can find and solve for the complementary angles, or we can solve as supplementary angles. Regardless of which way we choose, our answer will be the same. Okay? So I'm going to do it using supplementary angles because that's the first way that my brain would take to do it. If you solved it using complementary angles, that's okay too. Everybody understand that?
Yeah.
Okay. So, for this, 180 degrees is equal to y plus 112 degrees. We're going to subtract 112 from both sides. And 68 degrees equals y. So then the measure of this angle is 68 degrees. If we add 68 plus 22 plus 90, we will get 180 degrees. Okay? Questions? Yes.
Why did you like?
Okay, yes.
Then on the test, like, are we gonna need to label 112?
No, you don't need to label.
Label them underneath.
As long as you tell me what the measure of the dotted angle is and what the measure of the thick angle is, you're fine.
Okay.
I did that for clarification's sake and realized that now it's a little blurry than I had intended. Any other questions about this part? All right, let's look at the back. On the back, it says, Maria is wrapping a present for her brother's birthday. The box is a rectangular prism. If she knows the volume of the box, what will that tell her how much wrapping paper she needs to buy? Why or why not? Will knowing just the volume itself for a rectangular prism, will that tell you anything about side lengths?
No.
No. So, no. The volume tells how much would fit inside. The surface area tells how much wrapping paper would be needed. Okay, so the answer to number 9 is no. Volume will not tell us that for a rectangular prism. If it was a cube, we would be able to find a side length and then calculate the surface area based on that. But with the rectangular prism, there are too many variables. The numbers could be too different. So we cannot find the surface area based on the volume. Yes?
I put yes because you already knew the area before it started to find the volume. That's what you need to find the volume.
Okay, but it doesn't say that she found the volume. It just says that she was given